Okay, so what can you factor out from the first example, guys? What can be pulled out of here? Think, Kyle. And actually, let's take out a negative, so the leading term is positive inside. And there you go. But they said fully, so it's not the whole story, right? X minus 5, x plus 5. And there you go. What can I factor out of here? Yep. And that's the difference of two squares. So even though you don't really work with exudates all that often, it's the same thing as x squared minus 16, right? Just break it up into two separate factors. It's difference of two squares. And actually, can I break it down more? How about the x4 minus 4? How can I break that one down? Yep, x squared plus 2. Now, if you want, you don't have to do this, because at this point you're done, because usually, when we factor, we work with integers. But if you so desire, we have x squared minus 2, just so you know. That's the same thing as saying x minus root 2 and x plus root 2. I honestly, I don't care if you do that. I mean, it's good to know that root 2 and negative 2 are zeros of this function. But really, you're good at this point, because these are integers. So if you want to break down x squared minus 2, you could have done it if you want to. It's up to you. But yeah, that should be good enough, because you need to do the skill in order to do these graphs. So so if you think about it, we spent all this time in middle school factoring, right? Spent all this time, maybe you did algebra 1 if you're a senior. You got a second serving algebra, right? When you came here as a freshman. And in geometry, we reinforce. Algebra 2, we reinforce this. The reason why we care about this, because ultimately you're going to have to know how these graphs look, right? If you factor, you can do the graph more accurately. Why do we care how the graph looks? Because you're going to be applying calculus to this next year. If you're a senior, maybe in college. If you're a junior here at Sick Heart. And yeah, you got to know how the graphs look if you get apply calculus, because there's a lot of graphical stuff you do in calculus. And in order to have the accurate graph, you got to have know how the equation looks, know how to find x-intercepts and all that other stuff. So kind of matters. It's kind of getting you geared up for calculus next year. So let's look at this one. Describe the end behavior, solve the zeros, state the multiplicities. Okay, let's find the zeros first. That should be pretty straightforward, I believe. Come on. Let's go red so it stands out. Super easy. The first factor, what makes that 0? What makes x squared 0? Right? What makes the second factor 0? 19. What makes the third factor 0? And the last one? There you go. Those are your zeros. Essentially, you're saying each one equal to 0. That's all, right? Now, the multiplicities are simply the exponents where they come from. So 0 came from x squared, right? What was the exponent next to that? 2, then 3, then 4, then 5. Kind of nice. 2, 3, 4, 5. Okay. If it's even multiplicity bounce, odd multiplicity cross. I'll explain why in just a moment, why that's true. So B, B, C, C. Okay. Now, the next thing I want to talk about is something called a sign chart. Sign chart is going to look like this. Okay, let me erase this for now. Okay, so sign chart, not sure if you guys have done this before, but it's kind of important, especially for calculus. So sign chart is what you do is you take the x-intercepts, right? The zeros. You make a number and you put them on them. So where my x-intercepts stand, 0 and the front of the you put them on an angle. What you do, actually, before I even talk to you, how many intervals do I have? So how many regions do I break this out? Actually, 5. 1, 2, 3, 4. So yes, there are 4 partitions, but 5 intervals. So there's numbers greater than 19, numbers between 0, numbers between -4 and 0, numbers between -4, numbers less than -11. Let's look at 19. If I plug in a 20, because 20 is obviously in that far right interval. If I plug in 20, 20 squared, 20 minus 19 cubed, 20 plus 4 to the power of 5, 20 plus 11 raised to the 5th power. If I plug in 20, don't compute it, that's a really big number. Is why did positive or negative? If I plug in 20 with all this stuff here. Positive, yeah, because that's positive, that's positive, that's positive, that's positive. So what this means is that when I graph this, I should have resized this. That's my fault. That's all right. Should have thought that one through. But when I graph this, I expect, well, first of all, I expect to be crossing at 19. I expect this to be above the x-axis. Because the y coordinates are positive. That's what you did. When you tested the value in the far right interval, what you did is you plugged it into the equation, and you asked them, is y positive? Y is positive. Guess what? When you're above the x-axis, is y positive? It's positive. You're below, y is negative. That's intuitive, right? So I expect my graph to be above the x-axis in this region. That's very important. And it's going to pass through because of the odd. But actually, I'm going to explain the pass-through part in just a second. That'll become more clear in just a moment. Does that make sense? If I plug anything larger than 19, the graph will be above the x-axis because all the y values will be positive if I do that. Yeah, that's very important. Now, let's plug in a number between 0 and 19. Let's do like 1. If I plug 1 in. If I plug 1 in, is that positive? Yeah. Uh-oh. 1 minus 19, negative, positive. And you're also cubing it too, so it stays negative. Positive, positive. So you have a positive times a negative times a positive times a positive. When you have 3 positives and a negative, altogether that becomes what? When you negative, yeah. That is why we cross. What is the odd multiplicity? 19. X minus 19, right? That's why we cross, because y was negative before we got there and positive after, or vice versa. When positive got there and negative after. Bottom line is there's a transition for the sign of y. That's your product. That's why we cross and doesn't have any implicit. A lot of people just memorize, well, I forgot, I don't know. No. You understand, we visualize. You see the sphere now. Numerical understand, graphical understand, and algebraic understand, and it's not all of those things. When all those things are intertwined, the learning becomes really rich. Then you really become really good at this stuff. Yeah, totally. But totally is going to be a cross because we're seeing a sign change. Because we're seeing numericals happening. And algebraic, yeah, well, before we go through there. And then we'll eventually go to plus. Now this is where it gets interesting at 0. So it gets a little interesting. Let's plug in a number between 0 and -4. Let's say -1. Okay. Now, if I square -1, is that positive or negative? Positive. And still negative here, because you have -20 cubed. That's negative. But positive here and positive here. So again, we still have a positive, the negative, and the positive and positive. So in that next interval from -4 to 0, the y values are negative. Did the sign change at all there? No. There's no sign change at 0 because that's why we bounce. We're going to bounce at 0 because before I get to 0, the graph's below the x-axis. Guess what? After I pass 0, it is still below the x-axis. It's going to deflect. It's never going to pass the x-axis at 0 because of that even exponent. At this point, I kind of know what's going on now. I don't need to keep plugging these numbers because, to be honest, it's a pain in the ass to do. you will drive yourself crazy. And I have AP Calculus students where we do this often. In calculus, you do this daily, the sign chart business. So that's why I'm spending a lot. If there's any video you watch when you take calculus, it'll be this video. If I teach you guys calculus, or so you see me in the hallway next week, oh, I'm starting calculus. So, dude, watch this video. This is going to help you make sense because you do sign charts daily in that class. It's a big part of calculus or college. Some professors don't even do this; they just think you should know it. That's kind of lame because you should. They should teach it too. But here's the thing. Let me show you what you can do this efficiently because it does become be a pain to keep plugging these numbers. You're going to drive yourself nuts. Here's how I approach it. Now I'm going to give you like the efficient way for doing this. Okay, so start off the rightmost interval. Definitely plug in a number. Definitely plug in 20. See what happens. I got positive. Then ask yourself, 19. That was an odd multiplicity, right? That was a cross. That was a bounce. That was a bounce. And that's a cross. So I see a sign change here, no sign change here, no sign change here, sign change there. Bounces don't cause sign changes. Crosses do. That's obvious because we visualize it. Or odd multiplicities cause sign change. Evens do not. Yet even multiplicity at 0, -4, but odd multiplicity at -11, 19. That's how the graph's going to look. Now, I'm going to do the graph. And I know my end behavior is going to be, shoot, I didn't do the end behavior. I'll do that in a sec. What's the degree here? Let me add up all the exponents. 14? Yeah, okay. I should have done that earlier, but that's okay. Not a big deal. So let me delete some of this junk here. Ah, come on, man. Here. It's going to eraser. Okay. So 19, 0, I'm not going to dare find the y-intercept. It's the y-intercept plug in 0. Oh, it's actually 0. Never mind. Okay. So that's a guy multiply -19 cubed. No, don't worry about it. It's 0. So we're okay. All right. End behavior. Remember my leading term was x to the 14. So as x approaches -infinity, f of x will approach positive infinity, and vice versa. And likewise, if you do that. Okay. So let's do the graph. So I expect my arrows to look like this. We're going to cross at -11. Then we're going to hit -4, but we're going to bounce, curl down, bounce again, do that, and that. There you go. There's your graph. How low it goes, I don't know. That's calculus. So you'll do that calculus of what's very unneeded to come up. Yeah, I know they bounce here, so it's funny. Relative extreme, relative passes. So that's why I expect calculus. Desmos will be your best friend, just so you know. So what was the equation again? X squared, x minus 19. Always do shift 6 if you want to do exponents. 19 raised to the third power. Yeah, there we go. Yeah, you can see those low points are really hard to read. They get really low, but you get the general idea. Yeah, so anyway, there we go. Okay, let's go back to the. Okay, I really spent a long time with that, so I promise I won't do that for the other pages. This is generally what's happening again. So polynomial is a bunch of terms, right? That's why it's called poly. But more specifically, x is raised to some power, where the exponent is a whole number. The leading term is one of the highest exponent, right? X-intercepts, if you have it factored, like x minus r raised to some power, then r is the x-intercept. K's, even if you bounce, so you turn around, K is odd, you cross. If K is greater than when the graph flattens out, yeah, I'm not too concerned about that part. Yes, it does. That's okay. We don't need to worry so much about that for now. Calculus, we will. Y-intercept will, of course, plug in 0 for x. Odd even symmetry, yeah, I don't care about that so much about that either. The things I do care about are definitely this I care about. Definitely care about these two. Definitely care about this. This one, not so much. These two, not so much. And this I kind of care about, the number of turning points you have. I really care about this, though, crossing and bouncing. I care about that a lot. And then finding x-intercepts, too. So those are the things that matter most to me right now. Okay, that was easy. It wasn't too bad. Okay. So, all right. Let's try this here. So what's the degree here? And behavior? We're going to write as x approaches negative infinity. As x approaches positive infinity. So it's your leading term. What was the leading term again? X to the 5th power, right? So it's odd with a negative coefficient. So I expect the arrows to look like this. So it's positive infinity and negative infinity. It's okay to draw those arrows, but formally got to write like this with the infinity part. But yeah, that's what we expect to happen. Determine number, maximum number of extrema, 4. Find the real zeros, 2 with a multiplicity of 2. Negative 3 with a multiplicity of 3. Okay, so this will be a bounce. Well, that'll be a cross. Okay, we're good? All right. So we're going through this more quickly now. See it with symmetries. I don't think there are any. Yeah, because you have to replace x with negative x, but yeah, there aren't any, so don't worry about it. And sketch graph. So let me rewrite the equation again. Negative 5. My short-term memory is terrible. Is that right? Yeah, x plus 3 cubed. So 2, negative 3. Remember, this is a bounce. That's a cross. Arrows go like this. Y-intercept, oh boy, times 4 times 27. Negative 540, if you want to do that down here. That's the y-intercept, if you so desire. I think it's dead yet, right? The y-intercept? Yeah. All right. And we bounce at, we cross at negative 3. We bounce here and we come back down again. There's a graph. That's it. So, all right. So yeah, once you get the hang of it, you go pretty fast with this. Let's do it one more time. And I don't know why we're asking about symmetry, because you have all these shifts. You're not going to have symmetry here. I just don't know why we're asking that question. So, honestly, just ignore that. I just don't know why. I mean, maybe you might, but rarely going to have these because you're doing all these. Yeah, I'm just not sure why that's being asked. Anyway, the degree is 7. Sorry, degree is 5. The end behavior. What's your leading term, guys? It's not 7. Wow, I can't believe. No, it is 7. No, sorry. It is 7. Sorry, it's 5. That's not 4 is an x, but my apologies. It's 5. Yes, I know this. Yeah, leading term is 1x5, right? 1 times x to the 5th power, or just x to the 5th power. The end behavior is going to look like this.
Why is it 5?
Because you have x to the 1 power.
Oh.
Yeah, a lot of people forget that when they don't see a parentheses. It's still there. It's still an x. Now, if it's a constant, like 4 or 2 or whatever, then sure. Then the degree is 4. Totally. And that's going to be negative infinity and positive infinity. That's going to be 4. Your zeros are 0, -1, and -4. That's going to be once, twice, and twice. So that's a cross, bounce, bounce. Now we know this. Okay. Yeah, those are x-intercepts. And the arrows go like this. And remember, we bounce at -1 and -4. So I'm going to bounce at -4. Bounce here again. And do that. Does that make sense? I did that? Because otherwise you're going to mess up if you don't start bouncing across it, right? You bounce at the first 2, and you cross it. Therefore, for the end behavior, it's consistent with the procedure. So very important that we analyze this correctly. Because you aren't, so going back to calculus, you have to understand when things are increasing or decreasing. So that's a lot of part of calculus to be analyzed. You have to make sure you understand bounce across. That's right. Okay. Oh, true to my word. Even I was very long-winded. My first example got done by 9 o'clock. Perfect. I'm so happy. So you guys have 25 minutes. If you want, you could put a pretty big dent on this homework. It's honestly part D. Don't worry about part D. Don't worry about part D. Symmetry. I don't care about symmetry. I care about A, B, C, D, and E, and sorry, E and F. I think every time that's all the instructions are all the same. I don't care about part D. Just get rid of that. Find the zeros. Actually, they're all factored for you, I believe. Not mistaken. Not 2, not 1. So you got to factor. So factor 1 and 2, guys. 3, 4, and 5 are all factored. Again, I don't care about part D. Once you find the zeros, state the multiplicities, that's easy. Return number, that's what's less than a degree. Find the leading term so you can do the interpretation. Sketch graph. So it's kind of a little drill and kill in some ways. Might take more than 5 minutes. Maybe you get 2 or 3 problems done. I don't know. But we're all done.